For the external picture, I can simplify that distributed load. I can solve this for A and B. I'll sum the moments around B. I'll have a negative 30 from the 30 kip-ft external applied couple, minus 10 AY, plus 12.5 times 10 kip. AY is positive 9.5 kip. Forces in the Y, I'll have a negative 10 plus AY, which I just found, plus BY. BY will be 0.5 kip. Redrawing my beam, now that I know AY and BY, I will want here to draw those critical lines, or those critical points. One, the end of this distributed load, which is also where this point load is located. For the V diagram, I can ignore the 30 kip feet because that won't affect the V diagram. And then my other point load is up here at 0.5, but it's already on a line. All right, so now I go and I make my V diagram. Starting at 0, on the line there is no point load, so on the line there's not going to be a jump. I'll remain at 0. By the time I get to this critical line, I'm going to reduce my value of V by 10. So I'm going to add negative 10 to 0, and I'll be down to negative 10 by the time I'm on this line. I can now start putting in those slopes since I will have an idea of how the process works. This is a 0th order line. It's a uniform distribution. When I integrate it, it becomes a 1st order line or a straight line. Right? Only two ways that can be connected, or one way it can be connected, a straight line from 0 to negative 10. Now I'm on the line. I have to look for point loads. On this line, I have a 9.5 kip point load, which means I take my present value and I'm going to add 9.5 to that number. That will take me up to negative 0.5. So a positive jump. I'm now at 0.5. Now I look what's happening between the lines. Up here, there's no distributed load, there's no point loads, so therefore there's no change in my value of V between this line and that line. I'm at 0.5. I'm going to remain at 0.5 until I get to this line. I'm sorry, I'm at negative 0.5. I'll stay at negative 0.5 all the way through. Lastly, I'm on this critical line. There's a point load of 0.5 up. I'm at negative 0.5, so I go up to 0. So I've returned back up to 0. Start at 0, end at 0. To make the next step easier, I now want to calculate the areas between lines on my V diagram. So I have this first triangle that's negative 10 by 5. So this is going to be negative 25 kip-ft in area. Between these lines, I'm negative 0.5 times 5. It's a rectangle, so it'll be negative 2.5. And here it's also 5 feet by negative 0.5. This will also be negative 2.5 kip-ft in area. Now I'm ready to start my M diagram. Starting on the first line, there are no point moments, so on the line there's not going to be a jump. I'll stay at 0 while I'm on this line. Between the lines, I'm going to reduce my value by 25. I'm at 0. I'm going to subtract 25, so by the time I'm on this line, I will be at negative 25 kip-ft. This is a first order line, which I will write that since it can be tough to tell when it's small. When I integrate it, it's going to become a second order curve like we saw in the previous one. So it's either concave or convex. We want the general shape. We look at the value of v to determine the slope of m. It starts at 0. The slope ends at negative 10. So roughly, that'll be the concavity of m, the second order line. I'm on this critical line. I have no point loads, so there's not going to be a jump in my M diagram. Between lines, I'm going to reduce by another negative 2.5. I'm at negative 25. I'm going to go down by 2.5 by the time I'm at the next line. So again, not to scale, but just to kind of exaggerate it here, I'll be at negative 27.5 by the time I hit this point. This is a 0th order line. It's horizontal. It has no slope. When I integrate it, it'll become a 1st order line connecting these 2 points. I'm now on this line, this critical line, and I have a couple of 30 kip-ft acting on the line, which means I will have a jump, an immediate jump in my M diagram. I'm at negative 27.5. This is clockwise externally, which means it's positive internally. I'm going to go from my present value and then add 30 to it. I'm at negative 27.5. That will take me up to 2.5. Finally, between these 2 points, by the time I get over to the right-hand side, I'm going to reduce my current value by 2.5. I'm at 2.5. I subtract 2.5. That will take me to 0. This is a horizontal line. This must be then a straight line.